This is section 2.8, derivatives. Content objective 2, we want to write an equation for a tangent line using the derivative at its tangent point for the slope. So by the time we're done, you should be able to discuss the similarities and differences between objective 2 in section 2.8 versus objective 1 in section 2.7. So first we're going to start off by connecting to old knowledge. We learned in probably Algebra 1 and then again in geometry and algebra 2 that we could write the equation of a line provided we had a point and a slope. So that equation, which if you recall we did in 2.7, was y equals the slope times x minus the x coordinate plus the y coordinate. Well, the only new thing here is that we are replacing the slope with this notation that represents the derivative of f at the point of tangency. And again, you can compute that derivative using either of these difference quotients, though I have highly recommended that you try to stick with this one. You need to recognize this one when you see it, but this is the one that shows up most frequently. So for an example 1, we want to find g of 2 and then use it to find the equation of a tangent line at a point. So anytime you're dealing with equations of tangent lines, and I'm expecting you to write one, you will need to be able to write down a point and a slope that goes with that point, which in this case will be the derivative at 2. And then once you have those two together, you can write the equation of the line, which will be y equals that slope times x minus the x coordinate plus the y coordinate. So this problem is really asking you to compute that slope or that derivative at 2 using the method of your choice. I'm going to opt to do the h method, so I will need this g with a 2 plugged in, and a g with a 2 plus h plugged in, and then on the bottom I will have the h. If I plug the 2 plus h into this function, I will get a 3 times a 2 plus h quantity squared minus a 5 times a 2 plus h. There's my g of 2 plus h. Now I need to subtract g of 2. If I plug 2 into this function, I will get the y coordinate of the point that goes with 2. If I now multiply this all out, because, oops, that should be an h. If I multiply this all out so that I can get rid of that h on the bottom, I will have a 3 times a 4 plus 4h plus h squared, which is a 12 plus a 12h plus a 3h squared. Then I distribute the 5 and I get a 10 and a negative 5h, and then I'm subtracting 2. Now remember, if we do this properly, everything that doesn't have an h in it should vanish off the top, so that what we have remaining has a factor of h in it. If I factor the top now, I end up with an h times a 12 plus a 3h minus a 5. Notice that the h on the top and bottom will cancel, and now if I compute the limit, let h go to 0, I'll have a 12 minus a 5, which is a 7. I've now found that slope is 7. I can go write it in my equation of the line. With example 2, again, we are given a function and we want to write the equation of a tangent line at a given point. So just like the previous example, we need a point, which in this case is given, and we need a slope that belongs to that point, which will be f prime evaluated at 0. And then we will put those two pieces of information, or actually 3, because we have an input, an output, and a slope, into the equation of a line. Notice we have the slope times x minus the x coordinate plus the y coordinate. So to find that slope, we're going to use the definition of the derivative, which is the limit as h approaches 0 of f of 0 plus h minus f of 0 over h. And then we are going to realize that h plus 0, or 0 plus h, is just an h plugged into this function, and 0 plugged into the function is a 1. Notice things that do not have h's in them on the top cancel out, and I can reduce what's left and get rid of the h on the bottom, and then compute the limit to equal 0. So I can go put in my slope into the equation of the line, and if you want, you can even simplify that and get y equals 1. With example 3 now, it says if the tangent line at the point 4, 3 passes through the point 0, 5, we want to find f of 4 and f prime of 4. So we know that the point, which is 4, 3, actually comes from 4 and the output that belongs to 4. So right now we can already see that that f of 4 is going to be 3. So the only thing we need now is the f prime of 4. And f prime of 4 is the slope that goes with that point. And we were given 2 points on the graph of that tangent line. So that slope, which is 5 minus 3 over 0 minus 4, which is 2 over negative 4 or negative 1/2, is going to have to equal the f prime of 4. Now I'd like you to do your notes web exam problem and then be able to discuss the similarities and differences between this objective that we just did and objective 1 in section 2.7.